Hello, welcome back. Yesterday we were studying about the electrochemistry. Very much important chapter we have started with due respect to our IIT JEE mains and NEET concept. So yesterday we have already seen a few topic. Yesterday we have seen the oxidation reduction part. What exactly the meaning of oxidation and reduction? How we are supposed to use it, and then we have seen the basically we have seen at cathode we generally see that at cathode, okay, at cathode reduction is always takes place, we know this part, okay. And at anode when we talk about anode, there is a oxidation is always takes place. And whenever we see any kind of whenever we see a cell, in cell we have placed a named there was a one solution, electrolytic solution we have placed into that particular thing. Here we have placed Ca name, Ca, okay. And in that we have dipped two electrodes. Both the electrodes were made up of this platinum, okay. We have used this as a platinum, and then we have connected it with a external battery resource, okay. So whenever we write, we always look for the positive terminal, and after that we will go for the negative terminal. So yesterday, as per our yesterday's lecture, this positive will be nothing but our anode, okay. Because generally due to that, why anode? Because here A used to come over here and give its, because positive charge was over here, and this was our cathode over here. So whenever we study about this kind of a scenario, so let's take an example. Let's try to understand this topic with the help of example. Let's say we are using molten NaCl. We are using molten NaCl in this concept. So what will happen in this case? Why molten? Molten means NaCl which we have taken or melted at high temperature. So ultimately there will be no water in that particular thing. High temperature, we have done that process. So only Na and Cl molecule will be there. So in that concept, when we take molten NaCl, only NaCl will be there. So Na will be as a positive and Cl will be as a negative. So whenever we talk, so for this particular thing, whenever we talk like at positive electrode, when we write it at positive electrode, what will be going to happen here? Half oxidation reaction will be takes place over here. Oxidation reaction. So positive electrode means this Cl minus will be, it will deposit its one electron over here and it will become like this. So oxidation is taking place in this case, and so that's why it will act as what? Oxidation. For oxidation we use a anode part. So this is our anode part over here, okay. And at negative terminal, at negative electrode, or we can say that negative electrode, there will be half reduction reaction will be there. Half reduction reaction will be there. It will be called as a cathode. This part will be termed as a cathode. So at cathode, Na will be initiated. So in this case, Na plus will take one electron, okay, and it will convert to Na over here. So in this case, this is basically half. So whenever we write this, let's write this reaction over here. This both are half, and when we add them, this becomes a full. So we just remove the electrons from both sides. So this become Na plus Cl minus, and this gives us Na plus Cl. So generally Cl, it is always present in Cl2 form. So we take over here half Cl2 parameter. So NaCl, it always gives us Na plus and half Cl2. So this we have seen for the molten state. What will happen when we get a aqueous terminology, aqueous NaCl? So in aqueous NaCl, we will get H and OH also, H plus and OH minus, and along with that we will have Na plus and Cl minus also. So in that case, what we are going to do, what exactly we have to do over here, that we will see in upcoming few minutes. So there is one more this for this we would require an electrochemical series. We would require a electrochemical series. That is very much important. Okay, this electrochemical series, it justify how and which element first it will reduce or oxidize. It gives the idea behind that particular thing. Okay, so this is the general molten state. So there is one more thing that we are supposed to do, that is it is cumbersome to draw this particular cell always for all the question or every time. So what IUPAC has decided, IUPAC has given a one line representation. IUPAC has given a one line representation, one line representation for electrolytic cell, for a electrolytic cell. So in this particular in this particular terminology, what we do over here, that is we in this parameter we always draw like first whenever we see a cell like this, so we just draw two lines first. Okay, we always draw two lines, so there will be a right hand side and left hand side. This is our right side. Okay, I'm writing over here right side, and this will be our left side. Two sides we are having over here. Okay, so in between two lines, we always write over here, that is a medium. First what we write, the medium, and then we write what electrolyte we have taken. Okay, the second line, the second part, that electrolyte, and third, that is concentration and temperature. Okay, concentration and temperature. Or generally in many questions, this all three things will be given to us. Then always start writing from the right hand side. Okay, because on right hand side, always remember, on right hand side we write a reduction part. Okay, this is very much important. On right hand side we use reduction. What is a reduction? We represent at cathode. So here we write which electrode we have used, that is a cathode electrode will be over here. Okay, on right hand side reduction will be there, and extreme right we write cathode, and here we write the cathode product. After the comma we write the cathode product in this case. Okay, cathode product comma, then we have a cathode, and ultimately here we have to write the anode, that is our electrode over here, and for this we write over here anode product. We write a anode product, and we have seen that the cathode was negative in charge, and for this it was a positive in charge. So this is the one line representation for the electrolytic cell. So as per our yesterday's scenario, we have seen that we will try to represent this part over here. So what we will do, we will first draw two lines over here. So in that case, the medium we have taken, because there was no water, so ultimately the medium becomes a molten medium. So we write this as a molten. Okay, we write this as a molten medium over here. And then electrolyte, when we go for the electrolyte, this will be a C and A. Okay, Ca was the electrolyte, and there was no concentration, only high temperature was there. What we have taken? High temperature. So this will be a high temperature. So then we move towards the right side. Right side we always give the negative charge. And what electrode we have used over here? That was a platinum electrode. Okay, and the product we got on the cathode side. Okay, the product we got over here, it was a C. Okay, C was there, and then we have over here, that is a platinum electrode, positive charge, and we got A over here. So this much, this is the easiest part that we can do, right? Instead of drawing this cumbersome cell, we can use this part. And in many of, like in many terminologies, we get like platinum, this middle and electrodes we are given. We have to only just write the products over here. So this is the part that we can use and write. So for the same thing, like here, we can write for the NaCl also. NaCl is a molten. Here NaCl is there, high temperature, platinum. So what we are getting, that is very much important. At cathode, what we got over here, that is Na. So cathode was Na will be over here. Na, we can write Na over here, and Cl2 will be over here. At anode, we can write about this. So platinum electrode, we know that it is a inner electrode. So we can see this, that this is possible for this one. So we have seen that one line representation is very much easier than the writing a cumbersome process, or drawing a cumbersome process of a cell. So it is given by the IUPAC for our to make the work easier over here. So I hope you have followed with this one. So this is the first part for today's lecture, and in second part, that is very much important. Here we will see like the this electrochemistry or electrolytic cell. Whenever we study about the electrolytic cell, electrolytic cell, this electrolytic cells, these are divided in two parts. First one is a qualitative aspect. First one, it is a qualitative aspect. Qualitative aspect, and on the other hand, we have a quantitative aspect. On the other hand, we have a quantitative quantitative aspects. Okay, so in qualitative aspect, we are going to see like who will going to oxidize and who will going to reduce. That is very much important part, that who will be oxidized, okay, and who will be reduced. In this part, like in qualitative aspect, we see this terminology, that who will oxidize and who will reduce. So how we are going to find out who will get oxidized and reduce? So basically it depends on the factors. There are certain factors which affect the oxidizing and reducing properties. So factors affecting will be first one. So in this first parameter, what electrolyte we have used? Okay, electrolyte means the weak electrolyte, strong electrolyte will be there. So generally it will be in a liquid state. Okay, generally it will be in the liquid state. Second parameter, that it will be a medium. Okay, what medium we are going to use? So there will be only two type of medium, that will be a liquid or aqueous, we can say that, and there is one more medium, that is a ethereal. Okay, and another medium, it will be a molten state, we can say. Okay, and the third factor, that is very much important, that is a which electrolyte. Okay, electrolyte, sorry, not electrolyte, the electrode, which electrode we are going to use, inert or active electrode, that is also we have to study over here. So these are the three parameters which we have to keep in mind. Like in qualitative aspect, we are going to study about who will oxidize or reduce. and there are certain factors which are going to affect this particular, like who will going to oxidize and reduce. So first one is electrolyte, which electrolyte we are going to use, and the medium in which like water will be there or ethereal will be also present, and the molten can be possible, and the electrode, that is very much important. In quantitative aspect, like how much we are, like quantity means sorry, qualitative means how much we are going to get over here, how much, it will be oxidized in terms of oxidized, or it will be reduced. Okay, so how much it will be oxidized or reduced. So in terms of, we take this as a, either as a weight, that is a mass which is deposited at electrode. Okay, second one we can say, for if it is a gas, we take this as a volume, okay, for the gas over here. And third one we can say that in terms of current, how much current is passed and how much time we have used over here. So these are the electrolytic aspects that we have to study. There are two types of aspect, that is, first one is a qualitative aspect, second one is a quantitative in electrolytic cell. In qualitative we study about who will oxidize and reduce, and in quantitative aspect we study how much it will oxidize and reduce. So in qualitative there are certain factors, that is electrolyte, that is in liquid state, medium, that is very much important if we are using an aqueous. So who is going to get oxidized or reduced first? Either we can use a molten will be more easier than the aqueous state. And the electrode, yes, of course, two types of electrode we have seen, like active and inert electrode. There are more electrodes that we are going to study about. So qualitative aspect is also there. So in this parameter now, when we talk about the qualitative, so in qualitative aspect we can take example, that is we have just seen in earlier slide, that is in qualitative aspect. Let's study about over here the qualitative aspect. So in qualitative aspect, in qualitative aspect, who will going to get oxidized and reduced? So we can understand or see this particular thing with the help of a electrolytic cell. Okay, and in that electrolytic cell we have taken the molten state of NaCl minus. We have taken molten state of NaCl minus, and particularly there is one electrode, that is a platinum electrode. It is dipped into that particular NaCl solution, and which is connected with the battery itself. Okay, so this will be a positive end and this will be a negative. So here we have, that is our NaCl. NaCl, it is in a molten state, we can say that. Okay, NaCl we are having in molten state. This is our platinum electrode. Okay, both the electrodes are made up of platinum. So as we have, we are again, like factors like electrolyte we are using, that is in liquid state. Again, molten form is there, and electrodes are inert electrodes over here we are using. So in this case, what will happen? NaCl, it is in, so we can write NaCl, it is in molten state. NaCl is in molten state, and electrode we are using, the electrode which we are using, that is made up of, it is a platinum. So we know that platinum is a inert electrode. It is nothing but our inert electrode over here. So in this case, what we can write, again we will see that particular reaction, that at positive, okay, at positive terminal, at positive terminal, we can see that there will be at positive terminal, this will be completely positive in this case. Okay, this will be negative, 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 and negative. So negative will go over here. So chlorine will be there. It will go and it will leave its electron over here, and we get so Cl will give one electron. So we can write this as a half Cl2 gas. Okay. Why I'm writing half? Just because to balance the equation. So if we write 2 over here, so I wouldn't have written this particular thing. So I will write for your understanding over here. That is 2 chlorine will be there, Cl2 gas, 2 electron will be there. So this process will be known as a half oxidation reaction. Fine. Now on second terminal, we will be getting negative terminal. So here what will happen? Sodium will be in a plus state. It will be accepting this 2 electrons. So 2 sodium will be required, and it will be converted to 2 sodium metals over here. And this part will be known as half reduction reaction. Okay. So these two terminologies we are getting over here, and how much, and that is we have seen who will oxidize. So chlorine has oxidized and sodium has been reduced. So this is the terminology for the, basically we use it for the like qualitative, under the qualitative aspect. So we can write this as a 2Na plus 2Cl minus. We get over here Cl2 plus 2Na, and this becomes 2NaCl and Cl2 plus 2Na. So from here we can see that first part, that again we will repeating, like in qualitative aspect, factor affecting, first factor was the electrolyte. So our first part over here, the electrolyte we have used over here, it is nothing but the NaCl. We have used the NaCl over here, and medium was a molten medium, and electrode was made up of platinum. So who got oxidized? So oxidation was done on the chlorine part, and reduction was of the sodium part. So this is only for the molten state. What will happen if we have H plus and OH minus, and also Na plus and Cl minus? So for this basic terminology, we are supposed to use renowned electrochemical series. So electrochemical series we have to study first. So electrochemical series. So what exactly the electrochemical series? So it is basically for the reduction. It is based on the reduction potential. It is for the reduction potential. Reduction, we are familiar with the reduction. Reduction means gain of electron. Okay, the species which can gain electron. So that particular species is referred as a, if the more gain of electron, it will be having a standard. So we term that particular, because we have calculated all the values for in the electrochemical series. That's why it is referred as a standard reduction potential, and instead we can say this as a SRP. Okay, so electrochemical series is basically based on the standard reduction potentials. Reduction means gain of electron. So which species is going to get reduced first, and after that we can find out with that particular. Okay, we can also find out the oxidizing species. So first we will write all the elements first over here. Okay, so in this case we will be writing all the elements, like first how, like oxidizing, and first oxidizing to reducing. So whenever we write them, we always write them in the order of, like increasing order of their reduction potential. So first element, that is we write, that is lithium. Okay, first one is a lithium, and then we have a potassium, then we have barium. Okay, then we have a strontium, Sr. We say this as a Sr. Okay, Sr with, this will be in plus form. Okay, then we have a calcium, Ca plus 2. Then we have Na, that is in a plus. Then we have a Mg, okay, Mg plus 2. Then we have Al plus 3, Al plus 3. Then we take water molecule, okay. That is very much important that we have to keep in mind. Water for reduction, water for reduction. And then we use Mn plus 2, manganese will be there, okay. Then we use zinc, that is Zn plus 2, okay. After that, this is a increasing order, Zn plus 2. Then after that we use Cr plus 3, okay. Then we use Fe plus 2, okay. After Fe plus 2, the remaining part I am writing over here, okay. This is again the increasing order. Then we use cadmium, okay. Then we use cobalt, okay. Then we use nickel. Then after that, Sn plus 2 we use. Then we use Pb plus 2. Then H plus, hydrogen over here. Then we use Cu plus 2. Then we use OH minus. And then we have, that is Hg plus 2, Hg plus 2. Then Ag plus, silver. Then nitrate, NO3 minus. Then we have that is H2O. Again H2O is there. It is for the oxidation. This is for the oxidation part. And then we have a chlorine, Cl minus. Then SO4, 2 minus. And then we have a fluorine. So these are the very much important elements that we have to remember. And there are certain mnemonics that I'll be telling you. This will be for the tomorrow's lecture, but till then we are supposed to learn all of them, okay. Till then, because it is increasing order that we have to remember. Increasing order of SRP stands for standard reduction potential, and how we have calculated these values, that we will also see in tomorrow's lecture. Till then, please study hard, and if you have any doubt, you can just drop your message on this YouTube also. I'm also available on WhatsApp, and Telegram is also there. So if you have any doubt, so please update me. And till then, please study hard. Okay. Thank you very much. Bye bye.